Okay, so this is Unity Part 2, Cross-Platform Development Made Easy. Today we're going to be doing a 2D platformer as requested via the Slack poll that took place last week. And just in case anyone forgot, I'm Scott Robertson. I'm a Unity Certified Developer. Those are the main ways you can get a hold of me, tylerwebdev.slack.com or scottrobson@sbcglobal.net. Okay, so for anyone who hasn't got the engine installed already, that's link number 1. The assets that we're going to be using today is link number 2. So make sure that you're downloading those. I'll leave that up for a minute. All right, we're going to go ahead and move on to the Unity project. So we're going to create a brand new project. Make sure it's marked as 2D. Takes care of some of the presets for us. And I'm just calling it this. You can call it whatever you want. You can go ahead and create the project. Okay, and you should see something similar to this. And the first thing we're going to do is we're going to download a few assets from the asset store. So to do that, you're going to click on the Asset Store tab. If you don't see an Asset Store tab, the way to access it is to go to Window and then down to Asset Store. Okay. May take a minute for it to load. Be patient. It's kind of an internet browser inside the engine type thing going on. Okay. And we're going to go down to Unity Essentials. And in here we're going to see a bunch of free assets that we could download and use to produce our game. For the purposes of this particular game, we're going to be downloading 2. TextMesh Pro. So we'll start with that one. Now I've already downloaded it. You're going to see download on there. And then once it's on your platform, it'll just say import. So I'm going to go ahead and import it. And this is the import window. What this does is it gives us a breakdown of everything that this asset is going to pump into our project. Now this is extremely important because when you're developing an asset for use with Unity, you have no way of knowing what names or file structure the other developer is using for their project. So what this does is it kind of gives you a heads up and it'll let you know, hey, I'm going to be overwriting this file. Are you sure you want to do that? Now in this case we have a blank project, so all I see is new all the way down the line, right? But in the event that there was some type of an overlap, we'd want to be aware of that, and so this window will help us do that. And we can actually go in here manually and say, no, I already have that file, I don't need it again, or I modified it, I don't want to re-import it and overwrite those changes, all that fun stuff. Okay, so we're going to go ahead and import it. And this takes a bit because this particular plugin is actually integrating itself into the editor itself. So some assets, or actually most assets, work through DLLs or other kind of standalone items. But TextMesh Pro is one of those assets that actually does some editor integration, and so it has to do some stuff in the background as well. Okay, so now we can go into our project tab and we'll see TextMesh Pro folder there. Okay, so that means that we have it. And then for the next component, we're going to go to Assets, Import Package, 2D. If you don't have this, then that means that you did not get the Standard Assets checkbox when you downloaded and installed Unity. So in that case, you're going to instead go to the Unity Essentials tab in the Asset Store and download the Standard Assets package from there. Okay. However, this downloads everything. So for the sake of simplicity, we're going to try and just download the stuff we need, which is the 2D section. Okay. So what this does is it gives us a jump start into the 2D genre. We immediately get a player that we can use that's called Robot Boy. And we're given all the animations for him, the controls, the sprites, everything right out the gate. Okay, really useful stuff. And then we're also given things like mobile input control. which is handy if you're wanting to export it to iOS or Android, as well as different sprites for platforms and things like that. So we're going to go ahead and import that. Okay. So if we look in here, go to 2D, prefabs. These are the tools that we're given to work with, completely free by Unity. This character Rob is what we're going to be using today for our platformer. However, if you look at the platforms, they're just plain white boxes. It's not very entertaining, right? Well, thankfully, the asset store has a bunch of options that we can do. And so what we're going to do is we're going to go ahead and import that custom package that I provided. And this has a multitude of different assets all wrapped up into one. And it's going to say that there's overwrites, and that's fine. Okay. So anytime you see something like this little circle deal, that means that it's been changed. So it's going to be an overwrite. So we're going to go ahead and import all that. And now what I did for this project was I actually went through the asset store and I picked a selection of completely free asset packages for textures, sounds, even animations. We have an explosion animation that we're going to get to see later that's really cool. It's a little cartoony, like, blam type thing. Totally free off the asset store. Nothing that you're seeing here was something that I made custom. All of it's available for anyone. And the best part is it can be used commercially too. All right, so now if we go to our assets folder, we notice a lot more stuff, right? You'll notice at the top we have 000_my_stuff, which if you were here for Unity Part 1, you'll know is the folder that I create for all of the stuff that I've made, right? That's a good way of being able to distinguish it from any of the other assets that you've imported. Then we also see things like a 2D cartoon forest, animated 2D coin, and then in this folder we have some different sounds, a coin pickup and an explosion sound. And these are just .wav files. You can also use MP3s, supports vast majority of different audio files. And then we also have some casual game sounds for background music. A skybox that's a bit more cartoony. A game jam template menu, which really expedites the portion of the build for creating our scene management. So all of this UI at the very beginning here. This is actually a template. Drag and drop, done. Really handy stuff. And last but not least, we have Text Mesh Pro, the Toon Explosion animation, and our standard assets, which has our 2D that we already talked about. Okay? So, if you haven't already, go into My Stuff, Scenes, and double-click on Main. That's going to load up the game. I want to go over this with you real quick. Okay, so down here at the bottom, if I get rid of icons in the grid, we can see our robot, our player. Okay, and our player is comprised of a couple different things. We have a ground check and a ceiling check, and these are colliders. And what they do is they help to make sure that our player isn't hitting his head on something and that our player is standing on something. Okay? And then the player himself has an animator, which that's a whole nother tutorial. So we're just going to leave it as an animator. A 2D rigid body, which is different from the 3D rigid body we did in the first tutorial. With a 2D rigid body, we're only dealing with the X and Y axes. We're not worrying about Z. If you try and throw a 3D rigid body on here, you're going to get abnormal results because you're basically trying to balance a three-dimensional object on a piece of paper, on the edge of a piece of paper. And so it's not going to work. By using rigid body 2D, we're letting the physics engine know, hey, we're dealing with paper on paper, not a 3D object on paper, if that makes any sense. Okay, and then here for platformer character 2D, we have some additional elements to look at. Specifically, we've got max speed, which deals with how fast the character can move. So for example, right now it's set to 10. But if I change it to 1, you can see that now he's going to crawl, right? And if I change it to 100, now he's the Flash. Okay, so I'm going to change it back down to 10. And then jump force as well. Right now it's set to 600. Oh, I'm caught on the other side of the invisible wall. Let's try this again. Okay, so 600, let's change that to 200. You can see now he barely jumps at all. If I change it to 1,000, now he jumps really high, right? So when you're designing your platformer, these are values that you can mess with to increase or decrease the challenge. Let's say you wanted to hit a low grav zone. Oh, there's that explosion. A low grav zone, you might want to increase the jump force. A high grav zone, you might want to lower the jump force, and vice versa. You also have the ability to disable air control if you want to make it even more difficult, where the player has to set up the momentum prior to jumping because they can't control the player after. And then you also have the ability to filter out what is ground. So this has to do with layers. Every object is assigned a layer. By default, it's assigned to the default layer, right? You can create your own layers. So if you wanted to create a layer that was specifically ground, then you could say, okay, if the object is assigned to the ground layer, the player can walk on it. If not, then let the player fall through it. And that would work well for us, like an unfair Mario type situation, where you want it to look like you can walk on it, but the second you step on it, you fall right through. Okay? And then we also have an audio source on here. So in terms of audio, we have a couple different things to worry about. We have audio sources, audio listeners, okay, and audio mixers. Now, if anyone has ever done any soundboarding, the audio mixing component will be very familiar. Basically, if I open it up real quick, basically it's a simplified soundboard, okay? All your audio sources are assigned to a group, which in turn has its own channel mixer. So I can solo it, mute it, all that fun stuff, very similar stuff to what you would have on a soundboard. And the way you assign the audio is in the audio source component, you'll have an output, okay? And that output is where you assign the particular category. So for example, on the player, I have this output assigned to the sound FX component, or group, I mean, okay? So you'll see, excuse me, you'll see I have one for sound effects, one for music, and one for ticking clock. Another thing to note on here is we have the option to loop the sound. We have an option to have it be a one-shot, which we do via code. And then we also have the ability to play on awake, which sometimes you may not want to do. Like, for example, the jumping sound that the player has. We don't want that to happen the second the game starts, because the player's not doing anything. We only want it to happen when the player's jumping. Oh, okay, so we got some guys hanging out at the door. That's what my phone's blowing up about. Can someone unlock the door? All right. Okay, so where were we? Okay, yeah, so on the player, that's basically all we need to worry about with the player. We also have this script here that got to character control. This was a script that I created. And this basically is only there to handle interaction with the coin. Okay, so if you'll remember from our first tutorial, we dealt with the box collider and the isTrigger component of that. And I'll just do a quick review of that just to refresh everyone's memory. But all this script does is it checks to see if I've hit a trigger object, tells me what object I hit via its collider, and then I go ahead and tell my game control script that I've hit this object. Okay, so I'm referencing the game control script using a public variable, and then I pass that function the collider that I've hit. Okay, so then if I go ahead and open up this script, and I go to that function that I called player hit trigger, okay, you'll see that I check to see if the collider, if the transform, which is the positional data, actually contains the name of the object as well. If the name of the object starts with coin, then I know I've hit a pickup, and so I'm going to go ahead, play my coin pickup sound, and I'm going to set that coin as no longer active. So it's no longer visible, it's no longer interactable. And then I do some additional logic for the gaming side, things like keeping track of the score and all that other fun stuff. Okay. So that gives you an idea of how you can trigger other functions from other scripts through your player or any other thing you'd like to do that with. So if I go into the Unity editor here, you'll notice that the public variable shows up as something that I can fill, right? So my game control script is located on my main camera right here. So that's where this script is. So because I want to reference that function, I'm going to go ahead and go back to the player and click and drag the main camera over to that variable. And because I've already specified in the code that I want the control script, it doesn't reference the whole object, it only references that script, that component, if you will. Okay. And if I go back to main camera, you'll see something very similar with the game control script. I'm referencing various things like audio files, menus, prefabs, and other types of scripts. And you'll notice that the object changes depending upon what it is that I'm referencing. So for example, the ticking clock is an audio source component. So when I drag and drop my ticking clock object into that space, it gives me just the audio source component. That's important to note because in code, if I want to, for example, disable the ticking clock, the whole object, I can't just say ticking clock.setActive false like I can with a game object because I'm not referencing the game object. I'm referencing a piece of the game object. Okay. So, for example, if I said ticking clock.setActive, it's not even available, right? But what I can do is I can say ticking clock.gameObject with a lowercase g, and that tells the engine, okay, I want to reference the object that this component is a part of. And from there, I can now say setActive false, and I can now disable that object. Okay. All right. Moving on to the level building. So the way I built this level was using prefabs. And if we go into the level objects here, we have the ground and background. And the ground is comprised of basically just multiple blocks. Okay? But our blocks aren't just simple cubes like they were in the first tutorial, right? We have a bit of an isometric view going on here, where we're dealing with a flat surface, but we have this 3D effect going on, right? It's that 2.5D type view. And we need to stick with that when we deal with our player interacting with the object. So if I made the collider the full size of that object, here, let me drag it out just to show you. Okay, here's the full piece. If I made the collider the full size of that object, that means the player would stop right on top, just like that. Why is it showing the... Okay, we'll have to ignore the speaker. But anyway, it would show up right on top like that, right? Works great if that was a completely two-dimensional block, right? Like in Super Mario. But since we have an isometric view, we need to make it a little bit more different, a little more adjusted. And so if you'll notice here, with my box collider, I have 3 of them. And this is the beauty of having components as the basis for how Unity interacts with objects. So the object is the bucket, and the components are the different books I'm putting in that bucket. And I'm allowed, for the most part, multiple copies of the same book with slight adjustments. So for example, with Box Collider 2D, all a Box Collider is basically a box that tells the engine that I want to know when something interacts with this. Okay? If I didn't have any colliders on this object, the engine would never bother to tell me if something hits it or interacts with it or touches it in any way. Okay? But by having the collider on there, I can not only tell when an object touches it, but I can specify specific parts of my object and say, I want to know when they touch this specific part. And so that's what I've done here. I have my main box collider for the bulk of the center, right? And I've kind of created an invisible block for the player to sit on using the collider. So the visual block is the isometric one that we see, right? And that's rendered using the sprite renderer. So the sprite is this component here, and if I double click on that, this is the sprite, right? It's just a big atlas of different pics that I'm taking pieces of and saying, all right, I want to use this graphic or this graphic. Another way that you can use sprites is you can have different animations set up in here, and you can cycle through those animations as you're going through. But for this one, we're using different features: ground, trees, grass, that kind of thing. Okay. So the renderer gives me the visual aspect, but it does nothing for interaction. And so we have the first box collider, and that's what causes the player to rest on the collider itself, giving us that illusion that the player is in the center of that floating block, right? And then on the sides, I have additional colliders that have this extra material assignment called slippery. Okay? Now this is important. If you have no material assigned, it's going to act as an extremely grippy surface. So if you have a game where you want to do wall climbing, for instance, you would want that. So that way the player can hit the wall, they pause, they can jump again and keep going up the wall, right? If you want them to hit the wall and just slide down, as is very similar in platformer games, then you need a slippery material. Okay, so, but we also have a bouncy material and a sticky material, which is similar to the default, except it gives you additional things where you can actually control the level of stickiness and things like that. The bouncy one would be if you want them to run into a wall and bounce off, right? And we actually have that material assigned to our pink crate up here. Okay, so if I actually click on my pink crate, we'll see bouncy is the material that's assigned. Okay. Okay, so let me go ahead and move these back. Now if I go back to this pink crate really quick, we'll notice that it has a rigid body assigned. If I click on this, this ground, I don't have a rigid body assigned. Okay? A rigid body you assign to things you want to be able to interact with using physics. Not necessarily just like, basically if you're planning on moving it, would be the simplest way of putting it. So the floor we don't want to move, so there's no rigid body. But the box, we want to be able to calculate actual, gravitational influence. If I hit this thing at ramming speed, I want it to go flying. So we have a rigid body assigned to it so that way we're able to tell the engine, hey, I want you to calculate how this thing would react if it were real. And we have things like we can assign mass to make it heavier or lighter. We have our various drags, our gravity scale, all that fun stuff, all right there in the rigid body. So I guess another way of thinking of it would be if it deals with gravity at all, you want a rigid body. Okay? All right, and then we have our basic directional light, which for this particular setup doesn't really matter because we're dealing with primarily unlit textures. But if you were one of those fancy people who wanted to do the sprites that have the lighting effects going on with them, then we could go into that. But for what we're doing, it's just a light. We're good. So another thing to note for level building is sprites don't use the z-axis, right? So when you want to layer things on top of each other, you can't use the z-axis to do that. In 3D, if I want an object in front of another object, I simply grab it and drag it in front in 3D space. But when you're dealing with sprites, you have to do that using layers, specifically sorting layers. Okay, so if I go down here to my sprite renderer, I have a sorting layer and the order in that specific layer. Okay, so if I go to my layers, yep, tags and layers, under sorting layers, I can create custom sorting layers. If I want to say, okay, here's an example. If I wanted to do procedurally created levels, and I had a bunch of preset rooms just hanging out in the background, I could have those rooms assigned to specific layers and be able to toggle them on and off via those layers by bringing them to the forefront or background and all that other fun stuff. Okay, so I can basically hit a bunch of objects with one line of code. And then if I go back to here, the order in the layer, 0 is basically the furthest back. Okay, and then as you go up in number, it gets closer to the camera. Okay, but not literally. It stays in the exact same Z position. It's just telling the camera, draw this one after you draw this one. Okay, so that's why if we look down here at the tree, this tree has a, let me get the right controller here, has a bottom that pokes into the grass here. Okay, now if I change its layer to 10, the grass is no longer in front. And so I lose that effect of the tree being, part of the background. Okay. So let's take a look at the coins real quick. These are really cool. So it's a sprite, but it has an animation on it that makes it rotate as if it were 3D. See that? And all it's doing for that is it's just rotating through a series of pictures. But we're able to use an animator to do that. So the animator controller, this whole section here, is not limited to just those fancy 3D models where you've got the skeleton and all that other fun stuff. You can also use it for sprite animation. So if you want to create like a Sonic the Hedgehog effect, same thing. What this allows you to do is it allows you to control the speed of your sprite animation and also the order of the sprites, and also you can start and stop it. Okay, so anytime you're dealing with any kind of movement, whether it be a 3D object or a sprite, and it's not physics-based, you're going to be dealing with an animator more than likely. Okay, and then we also have a box collider on this one as well, but this one has is triggered checked. And if you'll remember from tutorial 1, what that means is we want to know when this object gets hit, but we don't want our player to be affected by it in terms of movement. So if I had the is trigger unchecked, I'd hit the coin and stop. Okay? But with is trigger checked, the player is allowed to move through the coin, and then the engine is told, hey, I've hit where this coin is located, what do you want to do? Okay. Another use of a is trigger collider would be for a doorway. If you have an automatic door system that you want to open and close. If you have a box collider that stretches a little bit in front of that door, the player hits that section, triggers the door open animation, allows the player to walk through. Okay. Okay. And then we have our canvas items. If anyone remembers this from the first tutorial, canvas items have some different options. Screen space overlay over here allows us to basically place it as a piece of paper that's resting over the camera lens. So everything else is behind it. Okay? And that gives us the ability to put in our menu systems, our score, our timer, and our pause button without it being hidden behind anything else. Okay? Another thing that you could do is, let's say you wanted to expand upon this platformer and you wanted to make the level larger, and you're moving the player and you're having the camera follow. Having a canvas that constantly renders on front of that camera, as opposed to statically in the scene, like an object would be, allows you to have that menu be in the correct place regardless of where the camera's looking in your 2D world. Okay? And then I also have attached to it a canvas scaler, which helps with adjusting it for various screen resolutions. Right now I have it set to free aspect. If I do 16 by 9, it adjusts automatically. 16 by 10, 5 by 4, etc. Without that canvas scaler, you'd end up with stuff off the screen. Okay. Event system. The event system is what the Unity engine uses to handle all forms of input regardless of platform. Okay. If you don't have an event system and you have a UI system in your game, an event system will automatically spawn. But the benefit of having the event system in there beforehand is you can make adjustments if needed. So for example, things like drag threshold. How many pixels do you want the mouse to move before it starts to count as a drag? The default is 5, but let's say you wanted to make it a bit more lenient. Like let's say you have an extremely high DPI device and 5 pixels on that device is barely a shake of your finger. Well, okay, you might want to up the threshold a little bit to give them a little more wiggle room. Also with the standalone input module, this gives you the ability to assign specific axes from the input manager to specific names that your game is going to use. So you have things like horizontal axes, vertical axes, submit button, cancel button. These are things that you would often affiliate with a controller, right? Horizontal axes, vertical axes, right? Submit and cancel are normally your start and back, depending upon the system you're using. And so let's say you wanted to map that to something different. You can do that in your standalone input module, and that'll affect all platforms. Now going back into your input manager, not the standalone, but the actual engine input manager, you can actually set up your various axes here with a negative and positive, as well as your different thresholds, what you want to count as dead, increase your sensitivity, all that fun stuff. Okay? Okay. So let's talk about game logic real quick. So with this game, we have a menu that comes up, I press start, the timer starts ticking, and my little robot has to try and pick up all the coins before I run out of time, right? Now I've got this pink crate here that I can move. If I hit it too fast, whoop, I fell off. If I hit it too fast, it falls off, and now I'm stuck, because I don't have a means of getting up to that other platform, right? So I need a way to be able to restart the game and place those objects back where they are supposed to be, right? And we do that via code. So if I go into the code base here, under Game Controller, a couple things I need for that. I need to know who the player is. So, am I looking at the right script? Yes, I am. Okay. So I need to know who the player is right here. I need to know where the crate is, right? So I have two public game object variables for those, and I drag the player object and the crate object into those variables in the editor. So if I go back into the editor real quick, main camera is where I have that script located, and you can see player and crate. Okay. I then need to grab the position of those objects at the very beginning of the game. So I would do that in the start function. If you remember back from tutorial 1, start happens once when the game first starts up, when that object is active. And that's important to remember. So if I have this object disabled, start won't run until I activate the object. Okay. And I've got spawn position and for both player and crate, and these are vector 3s. This is a little different than C++ if you're familiar with that all, and also I believe for many web languages. Vectors in Unity deal with positional space, X, Y, and Z axes. You can also use them for scale, and also use them for rotational data. Just make sure that you understand that it's X, Y, and Z. Vector 2 is X and Y. Okay. So since we want to know spawn position, that's positional data, we're going to put that into a vector 3. We grab that at the very beginning. So we have here player spawn position equals the player object. We want the transform because that's where all of our positional, scaling, and rotational data is. And we want the local position, not the global. And the reason why we want the local is because the global is going to basically factor in any of the parents that that object has. Now in this particular case, the player doesn't have a parent, but if it did, we don't want to set the player's position to the position of its of the object in relative. Let me try that again. We don't want to set the position of the object to the location of all the objects combined. We just want the player object itself. So for example, if I go into the Unity editor here and I go to coins, all the coins are under this parent of all coins go here, right? If I click on one of the coins that's inside that, my positional data has X, Y, and Z values, right? If I change this, all the coins change with it. So if I grab global position, it's going to give me 3.580172 plus the 5 that I put on the parent for X. Which then, if I go back and I set the position of the coin to that value, it's going to be wrong. Okay. Now, having said that, there are cases where you want to set the global position data. Like, for example, if you want to override its position completely, ignore the parent, then you want to know where it is with the parent included, and then set it from there. That's some extra code stuff. But for what we're doing, we're only doing the local position, which is going to be not factoring in any parent information. Okay. So if we go into here, we have player.transform.localPosition and crate.transform.localPosition. We save those at the very beginning, so that way when we restart, I can set those players, the player and crate, to those positions again. And that's how we get that restart effect. For the coins, we do something similar, except we're not really worried about position. They don't change their location. So instead, we just need to grab all the coins at the beginning of the game, store them away somewhere. That way we can reactivate them later. Now, in the first tutorial, what I had you guys doing was I had you registering every single pickup manually, drag and drop, right? That can get kind of tedious, especially for long-term usage. So for this one, what we've done is we've gone ahead and we've said, okay, we're going to create a container called coin container, just a game object variable, public, right? And we're going to reference that as all coins go here. So I'm going to keep track of that object. And at the start of the game, I'm going to use that reference, and I'm going to say get components and children transform, which means I want you to look at all the objects, including the one I'm referencing, and grab the transforms. So all coins go here, and all these coin objects, I'm going to get back from that command all their positional data, including their name. Okay? And what that allows me to do is I can create an array of that, and then cycle through it, check to see how many coins I have, and then save those to a list of game objects. Okay? And what I can do with this list is even if I deactivate the coin, like I pick up the coin, it deactivates, right? Even if it's deactivated and no longer visible, no longer active in the scene, when I go to restart, I can set it active again because I've already established a reference. Important thing to note, get components and children and anything else where you're fetching objects only works on objects that are active. So if I have all my coins not active, which is that little checkbox here, right? So if I turn it off, which coin is that? Let's grab one that's more visible. So if I grab, which one's this? This one, okay. See how it disappears? Okay. What it does is it deactivates everything. The transform data, the renderer, the animator, all that fun stuff all at once. Now it still saves it in the background, but it's not doing anything with it. Okay? So that means if I try and grab it using get components and children, I'm grabbing nothing because it's not active. So when I grab the reference, I need to do it while everything's still active, and then I can deactivate and I still have the reference. If I'm going to have it not active at the very beginning, my only option is to do a public variable and then drag it manually that way. The registering thing that we did with the first tutorial. Okay. Okay. Any questions so far? Okay, that's fine. Okay, sorry. Yeah, absolutely. You got the Unity asset file, right? Okay, so you have the project, you can play around with it, and if you have any questions, just hit me up in Slack. Yeah. Scott. Okay, so that actually brings up a good point. How you guys doing in terms of following along and everything? Because if I'm diving over in the deep end, then let me know, because I can always cater this to what you guys need. So following along okay? Everyone else following along okay? Yeah? Uh-huh. Yeah, if you had it set to install all the different okay, yeah. Well, I mean, even if you just install the engine and the standard assets, that's still a good 30 gigabytes worth of information, so it's going to take a bit. Yeah. Um, okay. So let's talk about the timer then. Let's go ahead and move on to the update function. Austin, thank you for coming, by the way. Yeah. Yeah, this session's being recorded, so we'll have it available if you want to rewatch it later and kind of hash through it. Yeah. All right. Okay, so the update function, if you remember from the first tutorial, runs every single frame that renders. Okay, so if we're running 60 frames per second, then it's going 60 times a second. Okay, um, that means it's not good for physics, like we talked about the first time. You have fixed update for that. You also have late update for things that you want to have to run after everything else is done for that particular frame. Okay, but for the timer, we want to do in regular update because we actually want to know what our frame rate is. Okay, and the way we do that is by accessing delta time right here, time.delta time. So delta time is very specifically the number of seconds it took to go from the last frame to this frame. Okay, and it breaks it down to the hundreds of placeholders. And what we do is we subtract that from our 30-second timer that we started at the very beginning. So this means that if we're running 60 frames per second, then we're subtracting 1 second every second, right? If we're doing 30, it stays at 1 second, regardless of the frame rate. If we had set this up as timer -1 every frame, it'd be all over the place, right? So by having time.delta time, we can have that set up. If I wanted to, say, for example, adjust this, let's say I wanted the timer to slow down, right? I can do that by putting in a modifier. We still keep delta time. That gives us our frame rate. But we can say, hey, I want it to go at half a second. And so what I can do is I can say I'm going to multiply this by 0.5. So now whatever the frame rate is, I'm taking half of that and subtracting it. Okay? Which is effectively half a second per second. If I wanted to double it, times 2, so on and so forth. Okay? And then we're updating our text. And we're doing that by referencing timer text, which if we go up to the top here, we're referencing that as a public variable. Again, one of those things that we drag and drop in from the editor. Question? What's the benefit of frame rate adjustment? In terms of the delta time? Basically, it's just accuracy. Since we're not sure what our frame rate is going to be, depending upon the particular platform, we need to make sure that we're synchronizing with a steady clock, and that delta time gives us that steady clock. Another way to do it would be to actually go into system.time. And kind of dive into the computer clock that way. The element in the view, like the coin, the coin makes an action. No, it's every single frame render. So for example, when I'm running the game here, okay, if I run it real quick, and I go into stats, I don't know if you can see it, but we're alternating between 70 and 74 frames per second. Okay? So, regardless of the frame rate, I'm always going to be subtracting 1 second per second because I'm factoring in how long it took for the frames to render, and that's how I'm getting my frame per second, if that makes any sense. So like for example, if I was only rendering 1 frame per second, delta time would be 1 second. If it's 60 frames per second, then it's 1 divided by 60, and so on and so forth. So the mathematical representation of that is 1 divided by whatever number of frames you're running at. Does that make a little more sense? Cool. Okay, but we don't want the timer running when we're in a menu. right? So we're going to use a really handy property known as active in hierarchy. It's actually something that didn't exist in version 4, so they made it a lot easier. Before you had to do this super complicated thing. Now it's just as simple as pause menu dot active in hierarchy. Okay, so I've got my pause menu and my main menu. Those are again public variables that I'm referencing. Drag and drop from the editor. That way, regardless of whether or not it starts off turned off or turned on, I know what I'm talking about when I reference that. And then I want to know if I'm in the main menu or if I'm in the pause menu. If I'm in either one of those, I don't want the timer running because then I'd be in the pause menu and the timer's still ticking down, right? Kind of defeats the whole point of a pause. And so I just check, is the main menu active in the hierarchy? Is the pause menu active in the hierarchy? If they're both not active in the hierarchy, then I know that I'm good to run the timer down. Pretty simple stuff. Okay, audio. Let's talk about that. So SFX source is an audio source. So, yeah, right here. SFX source, okay? And I'm grabbing that from the camera. So this script is assigned to the camera, and I have an audio source attached to the same object. So rather than drag and dropping and having yet another public variable exposed in the editor, what I can do is I can keep it private, so it's hidden, and reference the object that this script is attached to. Okay? And then I can grab the specific audio source component off of that object. Okay? So this is very fundamental ways of navigating the object component system in Unity, where if I'm wanting to grab specific things off of a game object and I don't want to deal with the whole thing, the way we handle that is through .get component or get objects and children or things like that, or get components and children, things of that nature. Okay. So once I have that assigned, SFX source is now referencing that particular audio source object or component, sorry. And so now down here, I can do things with it. I can do things like check if it's playing. If it is playing, I don't want multiple audio clips playing on top of each other. So I'm going to go ahead and stop the audio clip that's in progress. And I'm going to go ahead and start a brand new audio instance off of that source of the particular sound I want to play. So in this case, the explosion sound. Okay. This is only for this particular audio source though. So what this means is I can still have multiple audios playing, just using different sources. So go ahead.
So like I'm kind of lame on this, but
That's fine.
just to make sure I'm picking up what you're throwing down.
Yeah.
This part of the code and everything is basically like if your character then jumped up and touched the coin, then the coin would go bing while the music's still playing.
Correct.
Okay.
Yeah, so picture an audio source as, oh gosh, how much do I want to date myself? We'll call it a CD player, a boombox, okay? Picture an audio source as a boombox, okay? So every audio source you have in the scene is a boombox somewhere in your world. And you can position them anywhere you want. So for example, I have an audio source on my player, right? So if let's say I'm dealing in virtual reality and I'm dealing in 3D, right? If I want the zombie to sound like it's behind me, then that zombie needs to have the audio source that I'm playing the zombie sounds from. If I have the audio source only on the camera and I'm playing the zombie sounds through there, then it's going to constantly sound like I'm surrounded, right? So in order for the engine to know how to render the audio or transpose the audio, I guess, however you want to put it, to the speakers of the user correctly, you need to make sure that you're assigning the audio source to whatever is actually creating the sound. So for the jump sound, I have an audio source attached to the player for that. For my explosion sound, I have an audio source attached to the camera. Now I could technically do an audio source on the player, but I already have one there for jump, and I want the explosion one to happen even if the jump's still going. And I want to make sure that the explosion one happens nice and big. So even if the player is off camera somewhere, I still want that explosion to be heard. And so I have it attached directly to the camera. And the reason why that's important is because the camera is my listener. If I look here, this is my audio listener component, right? Those are the ears. You're only allowed one set of those active at one time in the scene. So, for example, In a multiplayer situation, only one audio listener can be made active. So that means each computer would have to have all the other players turned off for the audio listener, and only the player that's using this computer turned on. Okay? Otherwise, you get an error that says duplicate audio listeners, and it doesn't like you. Okay, so we've talked about audio. I'm referencing the audio clips here. You see explosion sound, pickup sound, victory sound. We have our different text objects. Any questions so far? Anything you want me to go down to into more detail? No? Okay. So that's basically the game. The rest of it is just designer work, placing your objects, making sure they're overlaid correctly, doing things like going into your inputs and making sure that you have the correct stuff referenced. For example, I had to fix jump because jump was assigned to the left bumper, and that's not very comfortable. So I got it assigned to the A button. But you can also have buttons do multiple things at the same time. So for example, joystick button 3 was also assigned to submit. So every time I would click the jump button, it would also pause the whole game. So you got to get that kind of stuff fixed too. Yeah, I think that's pretty good. I think that's the fastest presentation yet. And it's because rather than coding it from scratch, I just kind of threw the whole complete thing at you and tried to break it down. Oh, here's something that's useful. Let me talk about this then real quick, since we have some time. The explosion. So the explosion is something that I actually have to spawn in. You'll notice there's nothing in here that says explosion on it, right? So if I go to main camera, I have my explosion prefab, but it's down here in the project window. It's not in the scene. Okay? So when dealing with things like special effects, particles, or any type of instance where you're wanting to bring something into the scene that doesn't exist in there yet, the way that you can do that, especially when dealing with animations, is through instantiation, or spawning, if you will. So if I go to where I'm ending the game, I play the explosion sound, but then I also instantiate a copy of the explosion prefab that I was referencing. And I place it at the exact position and rotation of wherever the player's at. So even if the player is mid-jump, that's where I'm placing the explosion. And the explosion has an animation that's set to go off the second it spawns. Okay? With the animator. But what do I do once the animation's done? It doesn't automatically go away. It'll sit there and continue to play that animation over and over and over again, right? So at some point, I need to get rid of it. And the way to do that is to create a handler script, or in this case, what I called an explosion kill switch. And what this does, if I open it up, is a very simple script that requires an animator type on the object you attach it to, which means if I try to attach this to just a plain box, I'll get an error. It won't let me play. Okay? And that kind of control helps you to kind of control yourself in terms of organizing things and making sure you don't put scripts where they don't belong. Okay? So I could turn this into anything. I could say type of transform, type of audio source, type of whatever component I'm looking for. So by having type of animator, I'm ensuring that whatever object this is attached to, it has an animator component. So that way when this goes off, I'm guaranteed that it won't give an error, at least for a missing component. So at the very start, I'm going to call a destroy command, and I want to destroy the game object I'm connected to, lowercase g to reference the one I'm on, right? But I don't want to do it immediately. I want to do it after the animation is done. I want to do it the second the animation is done. So what I'm going to do is I'm going to grab that animator and I'm going to say, I want to know the length of the animation state you're currently in. And that's going to give me a response in seconds. And then if I want, I can add a delay to it. And so that spawns off this little function that sits in the background waiting. And the second the animation finishes, it goes, okay, you're done, and gets rid of it. Okay? So yeah. Oh, skybox. So you don't really see it because we've got all this stuff hiding, right? But we've got this kind of pixelated sky. I'm not sure why it's pixelated, but it's pixelated. Skybox hanging out in the background, right? Looks like this. And the way you can adjust what your skybox looks like, there's two ways. If we go into camera here, under clear flags, which basically just means if nothing is rendering, what do I show, right? I have the options of skybox, solid color, don't clear, and depth only. Depth only and don't clear are advanced stuff, so we're just going to talk about skybox or solid color. Okay? For skybox, it's going to generate whatever the default skybox is unless you have an alternate one assigned. You can either do that by grabbing your skybox material and dragging it to the skybox itself, which will change it. That'll change your default. Or let's say you wanted to have a day camera and a night camera and be able to toggle between the two. So to do that, we would go to our camera and we would actually assign a skybox directly to that camera. Okay? So we have a skybox component on this camera, and I can now drag and drop my Sunny 01A skybox there. And so now this camera only would use that skybox. All the other cameras would use the default. Little flexibility there. Okay? And that allows for cool effects like being able to transition from daytime to nighttime and having the clouds change and all that other fun stuff. Okay? This went a lot faster than I thought it was. I spent 4 or 5 hours going through building this, rehearsing it, and it just went pew, gone in a few minutes. So yeah, any questions? Anything you want me to dive into more detail? Anything that interests you? I mean, there's a lot of stuff here that's really dense that I just kind of gave the surface of. Nothing?
I'll say I'm really impressed. Being basically completely new to anything Unity, it really is. I mean, you said you spent 4 or 5 hours, which
Mm-hmm.
is, not that much time in the grand scheme of things. Came up with a functional prototype of a game. That's really impressive. I mean, it, lets me know that hey, this could be really realistic. I could get into this and make something.
Yeah,
So it's really encouraging to hear you show all this.
yeah, and the best part is most of that time was spent hunting down assets.
Right.
It wasn't even like actually putting together the game. It was going through the asset store and saying, okay, let me try and find a forest. Let me try and find this. Let me try and find that. And then once I had all the assets, then at that point it was just a matter of throwing it together. And because of the combination of the asset store and what Unity provides out of the box, literally the only stuff I created was 3 scripts. That's the only stuff I created custom. Everything else was supplied by either an asset on the asset store or through something that Unity includes by default. So, yeah. All right, so what's the difference between a regular object and a prefab? Anyone? Template, exactly, yes. So a regular object, the engine doesn't save it. It only has that one particular instance, so every single copy of that object requires more and more RAM, more and more resource usage. A prefab is when you take one of these objects, okay, and you drag it down to the project window to save it. When you do that, what happens is it saves that object to disk and then uses it as a blueprint or a template, so that way it only has to store the changes for every copy of the object rather than the whole object all over again. And the way we can tell what's a prefab and what's not a prefab is by the coloring. So anything that's white is not a prefab. Anything that's blue is a prefab. If it turns red, you lost the prefab. Okay. Another thing to, did I touch on this? I didn't touch on it. Okay, so another thing to note is you have this thing called static. Static is a really good way to optimize your games. If it's not going to move, make it static. Because what that does is it tells the engine, hey, I don't have to worry about this thing moving, so I'm going to render it one time and forget about it. Okay? If you don't have it marked as static, then it's redrawing it every frame. There's different kinds of static though. So let's say you only wanted to make it static for light mapping or for navigation, right? So let's say you have a lot of complicated lights going on, but you really only want to re-render the shadows for the character that's moving, right? It's like a Final Fantasy type situation where you're sitting in a marketplace, right? You have this really beautiful landscape. Rendering that every frame would be ridiculous. But if I bake all that and I make it static and it doesn't change, and I'm only changing the shadow, the lighting on the player, well, that's a lot easier to render, right? I'm only worrying about one thing instead of this giant mess. And so I would make the lighting, or in this case, the light map, static on all those different objects. Okay?
So if you had an object that wasn't static, it was requiring a lot of rendering,
Mm-hmm.
then you would in that object frame you would want to static.
You cannot do it in runtime. You have to do it prior to run. Yeah, because what happens is the static designation tells it what to do when it's compiling your build. So it's think of it like a macro or a flag. So when you mark it as static, it does some extra code that you don't see on the build time, where it's telling the build, all right, only render this once.
So really for like environmental elements is where it's most beneficial.
Yeah, yeah. Now you can do it in code in certain circumstances, but basically you have to make sure that you do it at spawn, um, which gets a little complicated. But it is possible. It's just more advanced code that you probably won't touch for most of what you do. So
Much more time consuming and difficult.
yeah, well, so that's the double-edged sword of Unity, in the sense that it makes a lot of things extremely easy, but because they try so hard to wrap complex problems into simple solutions, when you need to unwrap it and really dive down deep into the belly of the beast, if it you know as it were, it can get pretty complicated sometimes. Um, it's still doable, which is awesome. I mean, a lot of different programs that try and make things simple, they don't give you the option of diving down deep. But it does require some heavy lifting on part of programming and things like that. A good example would be shaders. Shaders are what actually tell the renderer what to do with a material. So if I go into my sprite, well, no, these are 2D objects. I'd have to go back into the first one. So let me open that up real quick. Okay, so the rollerball demo. If I go into the player, down to the bottom here, I've got different shaders, right? I've got the standard, then I have different flare FXs, all kinds of fun stuff, right? Well, I can also create custom shaders. And what a shader does is it tells the engine, this is how I want you to render this object using these textures and information, right? Light maps, texture maps, height maps, all that fun stuff. If you want to do something different than what the engine does by default, you can, but it requires you to write a custom shader and load that into the editor. Okay. There's actually specializations specifically for that, where people will spend an entire career doing nothing but graphical rendering, shader rendering, and dealing with that kind of code. So for those of us who don't like to deal with light math a lot, we just say, hey, I want a standard, or I want an unlit, or hey, I'm dealing with nature, so this is a tree, so I'm going to tell you it's a tree, and we're good. So things like that. Anyone remember what the albedo is from tutorial 1? Right here, where it says albedo under main maps? No? So basically that's giving you the color information. It's a fancy word for saying this is the color I want it to be. But I can make it more specific by applying a actual texture there And so then it'll tell me, okay, I want you to color it this way, but then I want you to apply this color tint to that texture that I provided. So that works well, for example, if I have a wood grain ball, right? And it rolls into some paint, and I want to tint that wood a particular color. So I have the texture assigned here that gives me the wood grain colors, but then I change the tint to whatever color that paint was. And it'll do the math for you of saying, okay, if I take this paint and I apply it onto this color, this is what it's going to look like. And it uses the shader to determine how that happens. Uh, Same with metallic. Metallic deals with the shininess of it, right? Yeah. I'm sorry, guys. I'm reaching. I honestly thought that presentation was going to take longer.
I got a question. Like, does it have any live frame elements that you can add? Like, let's say, for because it's a creative environment.
Mm-hmm.
Let's say somewhere in the field of a static image, you want some backlaying, pre-designated what might be some other type of live image, like let's say a TV,
Mm-hmm.
and inside the TV
Mm-hmm.
looks like TV playing
Yeah, you could do that.
in the
So
static
what you
image.
would do there is you would make the TV itself static, and that 3D model would have a transparent front, and then you can throw inside it, or if you don't have a front on it at all, you can throw on the front of the TV a well, actually, depending upon how you're doing it, you could make the whole TV static. Because if you're just playing a video file, the object itself would still be static. You're not doing anything with it. Now, if you wanted to get super crazy, like maybe for a stylistic approach, you wanted to actually have 3D models in the TV moving around, then those 3D models would need to not be static. But the TV could still be static because the TV itself is not moving. So yeah. Um, Anyone make any progress with their rollerball demo from tutorial one? No? Okay. Huh? Yeah, this was what was done in tutorial one. It's basically exact same concept as the platformer, except we're dealing with a ball instead of a robot jumping around. And there's no audio on this one. Um, yep. But this one uses nothing but stuff from inside Unity, no assets of any kind. If I wanted to make it more fun, I guess, more attractive to other players, then I could go in here and I could say, okay, I want to grab a model. I want to do a model. So I'm going to go into 3D models. I want to do a ball of some kind. Hey, look, a ball pack, and it's free. So now I can make it a spiked ball if I wanted to. And I could do some more fun stuff with it, where I could make it to where maybe I'm going through a level where I have different ramps and different obstacles that I have to burst through, and I could use the spike ball for that. And that took 2 seconds searching on the asset store, as opposed to going into Blender and trying to sculpt it myself. Right? Let's say I wanted to do some sounds. I wanted a good explosion sound, right? Let's look up explosions. Explosion pack here. Okay, well, all of these cost money, so I'm going to go ahead and say free only. Boom, look at that. True explosions. Or even pyroclastic explosion. Woo. There you go. So I can do stuff with that. If I wanted to make it specifically audio, then I could do sound. Retro noisy explosion. Retro sound effects. Detonator explosion. Free casual game sounds, which doesn't have explosion in the title, but then if I go into here, it has explosion in the description, so it pulls it. And then here under package contents, you can see what's in there. And it also gives you some suggested lists of items where it might contain this asset or related assets. So beginner-friendly music assets, right? Recommendations based off this, and also what customers also purchased in addition to this asset.
Now, like, let's say that you went to, like you were talking about, making the spike ball yourself.
Mm-hmm.
Does Unity allow you to like upload? If you were to go make your
Oh
own
yeah.
spike ball, Unity lets you
Oh, to the asset store? Yeah, okay, so that requires a little bit of setup. So anyone can upload to the asset store provided that they've registered themselves as an asset store developer with Unity. And the reason why you need to do that is simply just for Unity to keep tabs on you and make sure that you're not uploading viruses. So, so long as you've registered and you're not doing anything shady, you can upload to the asset store, set whatever price you want, all that fun stuff, no problem. But you're not limited to the asset store. Thankfully, due to the Unity package import thing, like what I did for this project where I had the Unity package, sometimes it bugs out, not sure what happened there. I think it was Google Drive, to be honest. But you can actually import custom stuff. So if I created this really cool menu system in one project and I wanted to use that same system in another project, well, rather than trying to figure out how to copy and paste what files from one project folder to the other, I can just right click on that particular thing. If, let me do it this way. Like let's say I wanted to use this whole scene in another project. I can just right click on that scene, say export package, and it's going to give me all the different items that that scene is dependent on and package it into one file. Okay, so I'm minimizing waste in terms of transferring data from one project to the other, and I'm still getting everything I need to use what I want to use.
The editor reminds me of like Adobe Premiere.
In a lot of
It's
ways,
got
yeah.
like module blocks where you open the next module.
Yeah, you can move these around however you want. So if like for example the project window, I could move it over here if I wanted to. And let's say I don't like the two column view. I just want the one column view. I can right click on here and I can say one column layout. I can just kind of change it up that way. Under window, I've got different items that aren't even shown. So for example, I have a test runner. If you're a test first type developer, I forget the official name for that, but you code the test first and then you code the code that fulfills the test. Unity has some support for that, not a lot, but it does have some support for it where you can create an editor test and say, okay, test collision. Spelled that wrong, but you get the idea, right? And then I can open this up. It's not liking me because I have multiple instances going. And now I can code out my test. Okay. Yep. So all kinds of fun stuff. Oh, another thing, if you're not big on programming, that's also okay because of an asset called Playmaker. There's other assets that are similar to it, but Playmaker is the most popular one. It does cost money, but basically what it lets you do is it lets you skip the whole coding aspect of things and instead use visual coding, where I can use a flowchart to specify what behaviors I want out of given objects. It's not bulletproof. There are some things that you just have to code. But especially for rapid prototyping development, it can be really handy.
So it's like a pre-establishment of like code blocks.
Yeah, it's exactly like code blocks. Yeah, basically you have a list of different options or selections. I'm trying to see if they have. They're not showing it. It's a state machine, is all it is. So you have your start, right? Let me make this bigger.
You're making it a lot funner than it was 20 years ago.
Yeah. So you have your start, and this is where, okay, I'm going to go into my idle state, and then I'm going to, when this happens, I'm going to do this. When this happens, I'm going to do this. But then it always goes back to the idle state. And so by using that state machine type logic, you're able to quickly develop out behaviors without having to write a single line of code. So long as that behavior is something that you can actually reference, that's been created in some form or another. If it's something that Unity does not have a pre-established behavior for, then that's something you have to code. Okay. Oh, here you go. Look at shaders. There's a whole category for nothing but custom shaders. And you got one here where it's called Beautify. Shows you the difference. So that's the Unity standard shader on the left, and then that's the custom shader on the right. Not much of a difference, but depending upon the look and style you're going for, it can make a big difference.
One on the right looks a little more dry.
Hmm.
Like the environment might be more dry.
Yeah. Yep. I think this one shows it really well, how you've got a lot more of the reds rather than the yellows. Yep.
Looks a little bit more blurred on the left.
Mm-hmm.
Kind of veiny looking on the right, like his arms or something.
Yep. And then you go into animations. So here's another cool thing about Unity. I don't know if you've ever run into this problem before, but if you've ever dealt with animating 3D models, you spend all this time, all these hard hours trying to get the model to animate just right, and then you switch over to the next model and you're like, crap, I got to do it all over again. With Unity, you don't have to do that necessarily, and that's because they've created a new standard using skeletal systems. So long as the animation uses the same or similar skeletal system, you can transfer the same set of animations from one model to another. So for example, if I have a dog, and I've animated the dog, and then I create a cat, if I wanted to, I could take the same dog animations and apply them to the cat model, and it would work out of the box. And that uses their new, what is it called? Mechanam? I think it's called Mechanam. But what that allows people to do is it allows them to go in and say, okay, well, since we can recycle animations, I'm going to do things like, hey, I want to create a bunch of warrior animations. You know, sword fighting, spear fighting, axe fighting, and you can skin that animation onto any model you want. So I might do a sci-fi one where I have a lightsaber and I'm slashing with it, and I can take the same animation and apply it to a medieval warrior using a broadsword. And it looks and works exactly the same. Let's say you get really lazy. They even do complete projects. So for example, 2D mountain bicycle template. Comes with the graphics, comes with the animations, probably even comes with the sound. All you got to do, take the levels they give you, design some more. Let's say you find an asset that you can't afford or you don't have a use for right now, but you really want to save it for future reference. You can do that using this button that's kind of hidden right here, add to wish list. And when you do that, you can click on the heart up here, and it'll show you all the ones that you've saved.
The pre-built packages like you just described, those are probably pretty good. Like if you just really starting to figure out how to tweak something.
Yeah, actually, that's what I would recommend. If you are not that experienced in a particular subject matter, audio, animation, modeling, one of the easiest ways that I've found that you can learn is to grab a set of free assets from the asset store in that category and look at what other people have done, um, especially the high-rated ones. And just kind of examine that and look at it and tear it apart and experiment with it. And if you mess it up, delete the folder, re-import it, you're good to go. There's no loss.
4 hours to build something.
Exactly. Yep. And always, 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 as a programmer, this was one of the hardest lessons I had to learn. Don't reinvent the wheel. Okay? If someone out there has already done it, don't waste your precious man hours trying to duplicate it. Right? Now, there's exceptions, obviously. If a guy wants $5 million for something that you can do for 100,000 in terms of man-hour cost, then you might want to do it yourself. But more times than not, it's going to be something like this one, Easy Save, where they want 24 bucks. And I don't know if anyone here has dealt with custom encryption scripts, but 24 bucks is more than worth it. Like me doing custom encryption scripts would easily cost a client thousands of dollars, if not more. For 24 bucks, I save them that money and save me a bunch of headache. Networking. That could be the next tutorial.
Nice.
Multiplayer.
Yeah.
So UNet is Unity's new networking API, and it's really, really cool. it actually makes most of the stuff you see here obsolete. But it's still really, really new, and they've got some bugs that they need to work out. So in the meantime, they still have all this stuff in here. But one of the things I want to point you guys to, if you want to get a head start and experiment with it, is Unity's network lobby. Let me get out of this category. It's probably under Unity Essentials. Yep, right here. So the network lobby gives you an out-of-the-box jump start on being able to create matches either through Unity's matchmaker or over local LAN to get you started with the multiplayer. Now, this doesn't automatically make your player data sync, okay? It gives you the menu system to allow you to connect to other players, okay? So the tutorial portion would be getting the player information to sync, but this would be what we would start with, okay? And the best part is that the Unity multiplayer service is completely free to use. So long as you're not actually professionally supporting a game, you can use their service free of charge, no problem. And even if you are professionally supporting a game, so long as your user base is under a certain amount, you're okay. So yeah, bookmark that if you want to get a jump start on it. It's a really good asset. And oh yeah, absolutely. Like, so for example, there is a complete project under Unity Essentials called Tanks, right? And there is a tutorial on YouTube that lets you take that and turn it into a multiplayer game using the network lobby and some other stuff. Um, you can use that in your own group. You just mess around with it, play with it, and you're not going to run into any problems until you hit, I think for free users, it's 20 concurrent users at the same time. For a small group, that's a lot of people. So let's say you want to make a Super Smash Brothers clone. You could do that, use Unity multiplayer, and you got how many? 8 maximum at a time? You got plenty of room. Now, once you publish it, different story. But as long as you're not publishing, you're good.